So chapter 12 started this conversation on climate change, and we sort of discussed where we are in terms of the science of climate change. And then chapter 13 discusses our policy responses. What are our options, and what has been done, and what could still be done. So we have a couple of different types of policy. One is adaptation, and the other is prevention. So, adaptation needs, as listed here in Table 13.1, are those things that we need to be doing to adapt to the fact that the climate is changing and has already changed. And then on the other side, we have uh, preventative measures, which are those types of policies that would help to mitigate climate change, help stop it or slow it down. So here are some more of those adaptation needs. Um, of course, more in your book on that. And then on preventative measures, these are things we've already discussed. So some of the options are of tax. So if you think about climate change as being the result of a negative externality, one way to fix a negative externality is to tax that externality. So a carbon tax, for example. So this illustration here shows that 1 gallon of gasoline is about 8.9 kilograms of carbon dioxide. Um, and so if we were to tax carbon with a tax of, for example, $50 per ton, then that would be the equivalent of 44 cents a gallon of gasoline. And there's a table in your book that talks through or that walks through the effects of a couple of different options of carbon tax on different uh, products, not just gasoline. But it's interesting what these taxes would do to our prices of these consumer products. Um, so with a price of about $2.20 a gallon of gas, that carbon tax would raise gas prices by 20%. And then the book goes into a discussion of how that would affect consumption of gasoline. So if the goal is to reduce emissions, then our goal is to reduce consumption, right? That's why we impose the taxes so that we have less consumption and then less emissions. So it's pretty clear, though not perfect. The relationship's not perfect, but it's pretty clear from this graph of prices on the vertical axis and consumption of gallons per person of gasoline on the horizontal axis, that the lower gas prices are, the lower consumption is as well. And we actually can measure that using what you may remember from a principles course in microeconomics, measuring what's called elasticity. So elasticity gives us a measure of how people's demand for a product changes when the price of that product changes. So another option that we have discussed for preventive measures is not just a tax, but also something like a cap and trade, tradable permit system. So a tradable permit system has the advantage that it allows firms to choose the least price, least cost method of reducing their emissions. So this shows some hypothetical examples of what it might cost to reduce emissions in three different ways. So one, maybe by replacing your old plant with a plant that has newer technology and emits less carbon. Or the one in the middle there, just replace some of your technology, try to be more efficient. And the third one is maybe by expanding forests, something like that, to reduce your emissions. So the point here being that different methods of reducing emissions cost different amounts to the firm. And so, but a system of carbon permits allows those firms to it incentivizes those firms to reduce emissions in the least cost way possible, so that then they can they can trade permits and utilize this system of permit trading. So those are the ways that we've discussed of using economic theory of how to correct for externalities in trying to reduce emissions. There are some other ways that have been proposed. So, for example, this picture here is from a study in 2004. And 2006 and 2011, so three studies sort of put together by the same authors, where they show the dotted line here is kind of the path that we're on. We're on a path that would double emissions by 2050 or 2060. But what we'd rather do is the dark blue line across the bottom, stabilize emissions and maybe at some point even decrease those emissions. And so what they've done in their study is they've proposed several things that would, several options, and you can look through some of them in the book, these options that if you did one of them, it would avoid 1 billion tons of carbon emissions, and they call each of these options a wedge. And so you see 9 wedges in this graph between the emissions doubling path that we're currently on and the path that we'd like to be on. And so their point is here's a list of things that each of them would avoid 1 billion tons of carbon. We'd like to be able to avoid 9 billion. And so pick 9 of them. For each of the things you choose and you're able to implement, you can bring this path down by 1 wedge. And so the goal would be to bring it down by 9 wedges all the way down to the goal or stabilization line. So that's one study that's out there. Pretty interesting to read through their list of wedges, their list of things, of policies that would avoid those billion tons of carbon emissions. Another study that's out there that, again, each of these is pretty tough to do because, as we've discussed in previous chapters, it's really hard to put dollar signs on environmental impacts. And so the previous study, the Wedges study, as well as this one, they can come under some criticism because of whatever your method is of figuring out these costs. But the point is, whether they're perfectly accurate or not, the point is that they do show that there are options, right? So this study, this picture shows on the vertical axis, you see the cost per ton of carbon dioxide or carbon dioxide equivalent that is abated or reduced, right? So, and on the horizontal axis, you see the number of tons that are abated by this policy. So each rectangle gives you an idea of how much carbon dioxide you can abate with that policy. So that's the horizontal width of the rectangle, and the vertical size of the rectangle shows you how much it would cost to do it. So what's really fascinating about this is these first few policies actually have negative cost, meaning they're a positive for us. They're more beneficial even in terms of money. We save more money than we spend to enact these things, these different policies. So, for example, efficiency improvements, LED lighting, insulation retrofit, we actually save a lot of money in energy consumption by doing those things, and we save more money than we had to spend to do them. And so you see this rectangle, it reduces, it abates carbon about 2.5 tons, but it actually saves us money. So the cost is negative, meaning it's a positive benefit. So the point of this study, or one of the points of this study, is that we can actually abate a bunch of carbon emissions all the way up to around here, around 12.5 or so, with policies that actually are financially beneficial to us before we actually start spending money on these things. And then when you get to the ones that have positive costs, so these over toward the right, that's when you have to do the cost benefit analysis and figure out, is it worth it to spend that money on a policy that abates this much carbon? So that's when you'd have to know sort of what is the financial or economic benefit of carbon abatement. But the ones to the left that are actually both environmentally and financially beneficial to us, those are the no-brainer policies that we should just be doing. This chapter then takes a turn and looks, instead of looking at policy possibilities, it looks at, okay, then what have we done? What sort of historically, what have we done to try um, to address climate change? And so here's a list. I'm not going to go through, but you can look at, this is a table in table 13.3 in the book, of different events in history where we have had international climate change negotiations. Um, the most recent of those was the Paris climate change negotiations, and where there's a whole section going through what different countries sort of proposed at this um, summit or meeting of countries. And the way it worked was countries would come. There was no one country or group of countries that imposes on other countries, here's what you must do, but each country came to the table with, here's what we promise to do, here's what we will do. And so countries were able to come up with their own goals and come to the table with those goals. So here are some of those goals. You can read more about more of them, but specifically notice the U.S. goal was to reduce emissions by 26 to 28%, based on the base level of what was going on in 2005, and the target was to have that done by 2025. So what that would do in terms of emissions is it would take us from the light dotted blue line here, which is sort of our business as usual. If we don't change anything, this is what we can expect to happen to emissions, and instead bring us to one of these places. So this is the 26 to 28% range. So if we're at 26%, we would be here, and 28%, we'd be here. And if all of the Paris pledges were to come true, so all the countries that came together and and brought their pledges, here's what we will do to combat climate change, then we would see a move from the dark blue line up at the top here, which was the business as usual. If no one did anything, we would see um, warming of up to 4.5 degrees Celsius. If everyone does what they said they would do, we'd be on the middle path here. This is where the pledges are. But what is clear is that those pledges aren't enough. What we really need is the lighter blue line to keep us below the 2 degrees Celsius mark that has been proposed as the mark that we should be trying to attain, is to stay below that 2 degrees Celsius of warming. Where did that come from, that target of 2 degrees Celsius? It comes from a study or several studies that like this one. So this study shows for a particular temperature increase, so across the horizontal axis, we have temperature increase. Here are some of the catastrophic impacts on the environment that would occur at that temperature increase level. So notice the gray bar here is the current sort of target, up to about 2 degrees Celsius is the proposed target. Here's what we should shoot for. We should shoot for staying below 2 degrees Celsius of warming. Where did that target come from? It comes from this picture that shows that's sort of where these really catastrophic impacts begin. If we allow warming to go even higher than that 2 degrees, we start to see more and more of these catastrophic impacts occurring at higher levels of warming. And so that's where that 2 degree target sort of comes from, is looking at what is the impact on the environment of different levels of temperature increase. The last piece of this chapter, and this is touched on in the previous chapter as well, but goes into the idea that global warming and the policies that we need in order to mitigate global warming and prevent further climate change have disproportionate impacts on different populations and different countries. And so we know that historically, the countries that are currently developed countries historically have been responsible for most of the emissions. Um, and so a lot of the problem now exists because of what the US and other developed nations did in the past. And so some would argue it's not fair then to put so much burden on currently developing countries to clean up and to enact these energy efficient policies that are so expensive when they aren't the ones who quote unquote did it. And so there's this proposal um, to to figure out what percent of the cost um, of mitigating um, climate change. So the cost of all these policies that have been proposed in order to keep us below that 2 degree mark, um, who should bear the burden of those costs? Um, and here is one method of figuring that out. It's been proposed, not been adopted, but it takes into account each country's capacity. So what is your ability to pay? And then also takes into account their responsibility. How much of the current problem did you contribute? What should your responsibility be for helping to clean up a problem that you helped to create? And so if this index here, the responsibility capacity index, which is the far right column here, gives here's what percent of the cost of cleaning this problem up you should pay. And it's based on how much are you able to pay? What is your capacity? And how much should you be responsible for paying? How much did you already contribute to the problem? So, um, anyway, just an interesting end to this chapter that brings us back to that idea that we need to keep in mind um, as we're thinking about what's the problem, how did we get here, and how do we fix it. We need to keep in mind how these things have different impacts on different countries and different groups of people, uh, and how to sort of spread the responsibility for cleaning up an environment that really belongs to all of us.